vertical angle. Okay, and all vertical angles are, they're opposite angles formed by two intersecting lines. Okay, so if we look at this diagram in the box, you notice how these two lines are intersecting? And I like to think they're making an X. Okay, so you have two lines making an X. The angles that are across from each other are vertical. So 2 and 4 are vertical angles, they're right across from each other. Okay, 1 and 3 are vertical angles because they're right across from each other. And there's this important theorem involving vertical angles. Involving vertical angles, again we talked about yesterday, is a theorem that has to be something that's proven to be true. So someone sat down, did some math, and be like, hey, this is true because of all the math that I just did. Okay, and it's going to work every time. And that theorem is, if two angles are vertical angles, then they are congruent, meaning that they're the same. Okay, so we look in this diagram, we just talked about how 1 and 3 are vertical angles, and 2 and 4 are vertical angles. Well, that means they're congruent. So 1 is congruent to 3, and 2 is congruent to 4. Okay, so again, we have intersecting lines, making an X, the angles across from each other are going to be the same every single time. Okay? So in this box, we're going to kind of do that math to figure out, well, why are they the same? Why are we allowed to say this? Okay? So we take a look at that diagram in the box. Okay? We can use what we talked about yesterday with the linear pair angle theorem to get a better understanding of why vertical angles work. I'm going to lower this down so you can see the diagram. Okay? When looking at this diagram, we can see that blank are a linear pair. Give me one linear pair in that diagram. Give me one. What do we know about their linear pair angles? They're right what? They're right. They're not right angles. They're right beside each other. They can't be right angles. Not all the time. They're right next to each other and they form a what? Straight line. Parker, give me two linear pair angles. 1 and 4. They are linear pair angles. Here's angle 1. They share this side. They're right next to each other. That side in the middle. There's angle 4. They're right next to each other, and they're creating a straight line. They're a linear pair. For the sake of the math, give me another linear pair with angle 1. What's another angle that creates a linear pair with angle 1? MJ? Angle 2. So we also know that angle 1 and angle 2 are a linear pair. Again, here's angle 2. It's right next to angle 1, and they're creating that straight line. They are a linear pair. Because they're a linear pair, we can say that, what? What do we know about linear pair angles? What do they add to? Says we can say that blank and blank, because linear pair angles are supplementary. What do we know about supplementary angles? 180. They add to 180. So we can say that the measure of angle 1 plus the measure of angle 4 equals 180 because of that theorem yesterday. We know they equal 180. We can say the same thing about angle 1 and angle 2. We can say that their measures also add to 180 degrees. What do you notice if both of these equations equal? They both equal 180. So, because they both equal the same thing, we can set them equal to each other. They're equal to the same thing, therefore those equations are equal to each other. Okay, so we can rewrite this as the measure of angle 1 plus the measure of angle 4 equals the measure of angle 1 plus the measure of angle 2. Because they both equal 180, they both equal each other. They equal the same thing. Does that make sense? We're going from here to there. Notice that each side of this new equation has a what? What do both sides of this equation have? Yeah, an angle 1. They both have an angle 1. Okay. Well, we can cancel the angle out by subtracting it on both sides. Okay? You can cancel things out in math, you do the opposite. Well, these are both positive angle 1s. The opposite of being positive is negative. And we are allowed, remember math, what you do to one side, you have to do the other. So we can get rid of these angles, cancel them out, by simply just saying, well, I'm going to minus angle 1 on that side. When I do to one, you have to do it to the other. That's a rule now. Alright? It's gone. So all we're left with after we cancel the angle 1s out is that the measure of angle 4 is equal to the measure of angle 2. We just showed that those vertical angles were the same. If we look back up at the diagram, we know that 2 and 4 are the same. And they're vertical angles. Okay? Looking at the diagram, we know 2 and 4 are vertical angles. We just did the math to show how we can get them to be the same. And that works every single time. That's why we can say that. Someone sat down and did this math. Okay? You could have done the same thing. You could have said, instead of saying 1 and 4, you could have said 3 and 4, 3 and 2. That's the same exact math. Okay? That's the same result. Questions over there? So now let's practice this a little bit. And the diagram below says angle NOP is 60 degrees. Find the value of the missing angle. What I really like to do is label my diagram as much as I can, especially with things like this. I like to think of these as little puzzles. It's kind of hard to solve a puzzle if you're not filling in those missing pieces. So I know NOP is 60 degrees. So here's NOP, that angle right there, 60. It also told us that this angle right here is 62. Another direction was written on the diagram. The first one we want to find a measure of angle SOR. So I'm going to label that. Like highlight. I love having highlighters in geometry. I think it's helpful. SOR. You can tell me the measure of angle SOR. 60. How do you know it was 60? Yeah, it's across from 60. We know this blue angle and the green angle are vertical angles. And we just learned that vertical angles are the same, so we can say it's 60 degrees. And I'm going to fill it in my diagram. That will help me find my other missing pieces. Gives you a good visual. Okay? The next one we want to find is the measure of angle PO2. That guy right there. Brandon? Be very careful. Is it across from 62? This right is it back to back with 62. So we have another angle in between. They're not across from each other. You're on the right track though. How do you get 58? Perfect. I like that. It is 58 degrees. Because what do these three angles make? 180. They make a straight angle. There, we can call it a linear triple because there's three of them, not a linear pair. Yeah, they make a straight angle. So we all know they add up to 180 degrees. So we can just subtract them. We just do 180 minus 62 minus 60. This is 58 degrees. Okay. MOS. I'm going to highlight that one. We want to find MOS. What's the measure of angle MOS? Celeste? How do you get 58? It's across from that red angle, which is also 58 degrees, meaning they are vertical. Okay. And the last one, QOR. This guy right here, QOR. What? You can read it yourself. What is it? 60. Now we got a 62 degree angle. Again, they're vertical. They're right across from each other. If it helps highlight the whole thing, if I highlight this whole thing, the sides that are making up those angles, you make an X across from each other. Question? questions over that. I like these kind of problems. We do these at our own block geometry. They're little puzzles. Like to fill in the missing pieces using the information. They're not hard math. You just have to remember those facts. Okay. Question? If you flip it over, we can apply this concept to help us find values of x, to help us solve problems. So these are the following diagrams. Find the value of x. Okay. Well, if we look at this diagram, and I'm handing in the cards out. Alyssa, I notice in this diagram that this angle has a 2x plus 50, and that angle has a 100. What kind of angles are those? If we look, we have two intersecting lines. They're making an X, and they're right across from each other. What do we call angles that, when they have intersecting lines, they're across from each other? What do we call those? Start with a V. Vertical, yeah. We have an X, they make an X, they're right across from each other. We call those vertical angles. What do we know about vertical angles? Yep, they're the same. So they're the same. Ellie, how can we set up this problem? What did we just say? We just said these are vertical angles, and we know vertical angles are what? What did we talk about at the beginning? We said vertical angles were they're across from each other. What do you know about their measurements? They're the same. So they're the same. How can we set up the problem? Set them equal to each other. Good. They're the same. We can set them equal to each other. Right? And then solve. Yummy, what's our first step in solving? Yeah, subtract 50 on both sides. To get x by itself, what do we have to do to get x by itself, Zoe? Divide by 2. And x equals 25. Do we have to plug it in or anything? No. Didn't say to. Let's find x. We did. So that's. So we take a look at B. I notice that this angle has an x plus 2 and that angle has a 3x minus 54. Right. I also notice I have two intersecting lines. They're making an x. And these angles are right next. They're across from each other. So Nyla, we would call these what kind of angles? Vertical. Very good. Louis, what do we know about vertical angles? Very good. They are equal to each other. And if they are equal to each other, Ryan, how can we set up this problem? What do you mean by combine? Yeah, we equal them to each other. Vertical angles are the same. They are equal, so we can set them equal. And then solve. Parker, what's our first step in solving? Good. Move the x over. I'm minusing it, so we get 2x minus 54. Josh, what's our next step going to be? What do we have to do with the 54?
Yeah, put it on the other side.
Good, we got to move to the other side. By adding 6. And then our very last step when solving, Maddie, what are we going to do? We get 20. Again, if you have vertical angles, you make an X. They're vertical. They're across from each other. They are the same every single time. That math we did on the front showed us why they're the same every time. So when to solve, you always just set them equal. Linear pair angles that are next to each other, they make a straight line. We set them equal to 180. Vertical, we set them equal. Have to make sure you know the difference. Okay. Example 3 says, using the diagram below, find the value of the missing variable. We're going to use this diagram. We need to find x, we need to find y, and we need to find z. tell me the measure of x. Measure x. You want to move on? Or are you going to give another one? Do you have a question? No. Oh. I'll move on. Nyla? 55. How do you know it's 55? Vertical to an angle that's 55. Again, we have an x here. Whenever we make an x, think vertical angles. I like to think it's like two V's that are back to back. V stands for vertical. And we make an x. They're right across from each other. They are the same. So this angle is 55. X has to be 55. Who can tell me what the measure of y is? Empty? 125? How'd you get 125? Good. How'd you know that these were 180 degrees? Yeah, they make a straight line. They are a linear pair. Here's a 55-degree angle. Here's y. They're right next to each other. They're right on this straight line. They're a linear pair. They add the 180. Just do 180 minus 55. I'm going to fill those in. So I'm telling you guys to fill things in. I'm not. So this is 125. This is 55. What's the measure of z? Brandon? Yeah, 125. How'd you get 125?
Because it's like opposite.
Very good. These two are vertical. Again, when you make the x, two intersecting lines, they're making an x. They're across from each other. They're the same. So this is 125. That's going to be 125. Right? Was there another way to get the same answer? I don't have another way. First we had two different ways. And both of them were correct. What do we know about z and 55? What are they for? They're 180. They form a linear pair. So you could have also just did 180 minus 55 and not 125 if you didn't recognize that those were vertical angles. That's what I like about geometry. A lot of times there's more than one way of getting the correct answer. So just sometimes you just have to look at a diagram and it's how your brain works. Okay. Questions over that? Okay. So we move on to this next one. We can apply this same kind of concept, incorporating vertical angles and linear pair angles to solve for x. Okay? In the diagram below, says the measure of angle 1 equals 3x minus 8. Okay? The measure of angle 3 is equal to 2x plus 72. And the measure, oh, sorry, don't do that. Forgot to change this. You get clean numbers, but they don't make sense. So we're changing this, scratch out that 1, and change the 7 to a 1. So it's just 4y plus 4, and then 2x plus. It does work out if you work ahead. You do get clean answers, but they make absolutely no sense to the back. Don't use those numbers. Okay. So we take a look at, again, we're going to fill it in. 1 is 3x minus 8. 2 is 4y plus 4. And 3 is 2x plus 12. Fill those values in. Always fill in your diagram. Gives you the visual. Yes?
4y.
No, I just changed it. I literally just said the numbers are off.
Oh.
Yeah, literally just changed it. Make it a 4y plus 4 and a 2x plus 12. You do get clean numbers, but they make no sense. They don't make any sense with what we get with our diagram. They don't work with it, so. Well, which variable do we have to solve for first? Why do we have to solve for x first? Good, yeah. There's two equations that have x, right? Two expressions that have x. There's no other expression that has y. So we have to find x first. It's impossible to find y. There's no number we can pair y up with. There's no other y expression we can use to solve for y. We have to solve for x. Sometimes it's the other way around. Sometimes there's two y's and only one x. So we have to solve for y first. Right? Well, what do we know about these angles? MJ, what kind of angles are angle 1 and angle 3? Yeah, they're vertical. Very good. Again, we have an X, they're across from each other, they are vertical. Okay? Well, if they're vertical, Trent, how can we set up this problem when we know about vertical angles? Yeah, very good. They equal each other. Because they're vertical angles, we know vertical angles are equal. So in order to solve, all we have to do is just set them equal. And then solve. To solve, so that's what's our first step in solving. You ready? So we get 20. What's our next step? Chris, what are we going to do next? Oh, subtract 2. X. So we get that X is equal to 20. So we found X. Perfect. Now we have to find Y. Parker, what do you think we have to do to find Y? Or do you have a question? You sure? Do you have a question?
No,
What are you going to say? Okay. You're fine? Okay. Gabe, what do you think we have to do to find Y?
Yeah. 1 and 3 is like 52.
Yeah.
And you like subtract 180 from 52 and move it 128 and 728 equals 4.
You got it. Okay, very good. What Gabe did. You notice I have nothing to help me set up an equation with Y. There's no other Y's, there's no other numbers. Okay? But he noticed that this angle right here, angle 2, and this angle right here, angle 1, were what? What kind of angles are those? What? Equal 180, they're in a linear curve, they make a straight line. So if I know I add 2 and 1 together, I'm getting 180 degrees. What's the problem if we set up an equation like that right now? If I wrote 4y plus 4, don't write this down, I'm just writing out for an example, plus 3x minus 8, what's wrong? Equals 180. What's the issue here? Two different variables, right? Didn't do that yet. But as Gabe said, well, you can easily get rid of the x by taking your x value and plugging it in. Right? So we can take 20 and plug it in for x and get 52. So I know this angle right here is 52 degrees. We know these are a linear pair. We know they add to 180 degrees. Okay. So we can do 4y plus 4. I don't know if I want to write on the side of the board. Plus 52. And all weird. Equals 180 degrees. Okay. You can also, Gabe said, just subtract 52 from 180 and set equal to that. That's fine too. I try to be consistent in what we've done. Both ways are perfectly fine. And then solve. When we solve, Logan, what's our first step? Good. When we combine like terms, 4 plus 52 is what? 26. Colton, what's our next step in solving? Good. 456. So yeah, what's 180 minus 56? 124. And then our last step in solving this problem, Ashley, what are we going to do? Divide both sides by 4. And 124 divided by 4 is 31. Sometimes I incorporate both. Yes.
Alright, so from earlier on, I said we're going line.
Yeah.
So, like, how's the bigger angle like a smaller degree?
That is a great question. Our diagrams are not drawn to scale. That's going to happen. You're going to have a really little angle be a very big number. That's just because it's really hard to constantly come up with things that work out with the diagram. Sometimes it just happens. So things aren't necessarily going to be drawn to scale. It's just hard to find diagrams that match perfectly with our numbers. It's just hard. So that will happen. Yeah, because when this is 52, say this is 52 and that's 124. That doesn't look 124. I agree with you. But that's just going to That's a great question. I like that you asked that. Questions over that. Don't be like, wait a second. That doesn't look at 124 degree angle. This is how it is. Okay. Questions over that? One more. Okay. Use the diagram below to answer the following. Let's say pair of adjacent angles. What does adjacent mean again? We talked about it yesterday. Adjacent means to be where? What is it? Right next to each other. So we have to say two angles that are right next to each other. I'll list the first one. I'm going to name this angle right here AOE. Can someone tell me what angle that's adjacent? AOD, very good. AOD. They're right next to each other. They're sharing a side. But then you have the other side going in a different direction. Okay. What would be another angle you could have said? Kenzie? EOC. That's also adjacent to the green angle. List a pair of linear pair angles. You can give me a pair of linear pair angles. What? AOD and perfect. AOD and angle EOD. And right next to each other, they share that side right in the middle. They create a straight line. Okay? Who can name me? And that's not the only pair of linear pair angles, too. You could have said, like, this angle and that angle. Those are linear pairs. So there's more than one answer with that one. Parker, can you give me a pair of vertical angles? Perfect. Angle AOD. We use AOD a lot in this one. And angle COD. Again, I think it's easy to tell linear pair angles because you can just name angles that are next to each other on a straight line. Vertical ones might be harder to tell. What I like to do, find two lines that are making an X. It's like this line's going all the way through, that one's going all the way through, they're making an X. And then you can tell, oh, okay, these two are across from each other, those are vertical. Or you could have said that these two angles are across from each other, they're vertical. Okay? So make an X, pick two angles across from each other when you're trying to figure out vertical angles. Questions over that? The rest of the time is yours.